we spent a lot of time looking at our special right triangles and our trig functions. So now what we're going to do is we're going to make sure our phones are put away. And we're going to look at what we call reference angles. We're going to bring those into our special right triangles and finding angle measures given those. So a reference angle is the angle that is formed between the terminal side and the x-axis, okay? And it is always, and this is very, very important, it is always less than 90 degrees, okay? The reference angle will be between 0 and 90 degrees, okay? So, whenever I have an angle that ends in quadrant 2 in rotation, so between 90 and 180 degrees, the reference angle is going to be whatever that extra rotation is that would get me to 180 degrees. When I move into quadrant 3, I'm between 180 and 270. The reference angle is that extra rotation from 180 degrees. And then in quadrant 4, which is between 270 and 360, it's that extra rotation that would get me to 360. All of those values will be between 0 and 90 degrees. The importance of the reference angle is that sine, cosine, tangent, all of our trigonometric functions in our other quadrants past 90 degrees are the same when we look at the reference angle. So if I have a reference angle of 30 degrees, it will have the same trigonometric function values as an angle that is 30 degrees. The only difference is that the x values become negative. So some of the signs will change on the trig functions. Any of the functions that use x in the ratio will change and be negative instead of positive. Okay? So, common mistake is using the y-axis. We don't use the y-axis. Don't use the y-axis. It's always the x-axis. Okay? So you're forming a triangle using the x-axis. That's where we get our reference angles from. Okay? So we want to find the reference angle for 218 degrees, okay? So I'm doing a full rotation here of 218 degrees. What is this angle right here? When I have an angle that stops on the x-axis? 180. So how would I find the difference between 180 and the 218 that I have in the rotation? Subtract it. What's 218 minus 180? 38 degrees. Yeah, actually. 218 minus 180 gives me the 38 degrees. So if I have a reference angle of 38 degrees, all of my trigonometric function values will be the same as the measure of 38 degrees. The only thing that's different is some of them will be negative now. Okay? Alright? 1,387 degrees. I want to find its reference angle. So the first thing we have to do is get a coterminal angle between 0 and 360. So how do I find that coterminal angle that's between 0 and 360? How do I find coterminal angles again? That's a good guess. Because that's usually the answer. But not when we're trying to find an angle. Yeah, we're going to subtract 360 until we get something between 0 and 360. Okay? Alright, what's 1387 minus 360? Okay. Is that between 0 and 360? So now what do we have to do? Subtract it again. Okay, is that between 0 and 360? Do it again. Is that between 0 and 360? Yeah. Okay. So that's our reference angle. Guys, let's lock it in, please. A lot of side chatter going on. Let's cut it off. So 307 is my reference angle. Okay. If I were to do a full rotation and finish this pink line here up to here, what's that angle measure? 360. So how do I find the difference between 360 and 307? Subtract it. A whole lot of subtraction going on. 360 minus 307. 53. So our reference angle is 53 degrees. Alright, so general process when we're finding our reference angle. We're either subtracting from 180, subtracting by 180, or subtracting from 360, depending on what quadrant we're in. So we saw that when we were in quadrant 3, we subtracted our angle measurement from 180 degrees. If we were in quadrant 2, we would subtract our angle measure from 180 degrees. If we're in quadrant 4, we saw we subtracted our angle measurement from 360 degrees. If we're in quadrant 1, the angle itself is its reference angle because it's already less than 90 degrees. Okay? So that's how we find our reference angles. So now what we can do is we can use our reference angles to find those trig values for angles greater than 90 degrees. For now, we've been doing, for the most part, less than 90 degrees. So to find the trig values, we just need to find the reference angle to start. What's the reference angle for 210 degrees going to be? I've got my full rotation here, 210, and this is 180. Do 30. How'd you get 30? 210 minus 180. 210 minus 180 gives me my 30 degrees. So my trig functions for 210 degrees are going to be the same numbers as my 30 degrees. We talked about the special right triangles and being able to use those to find all your trig values. Okay? The 30, 60, 90 triangle and the 45, 45 triangle. Since we have a 30 degree angle, we're going to be using our 30, 60, 90 triangle. I want to remind you and emphasize that you should be able, by your quiz, to construct this triangle on your own. Okay? So either memorize what that triangle looks like, or the process of how to make it. Alright? We went through that starting with the equilateral triangle, cutting in half, using Pythagorean theorem, or you can memorize the triangle. I don't care which, but you need to know the special right triangle because you need to be able to find these values, the exact values, and your calculator is not going to give you all the exact values. Okay? So, we need to find this ratio. Alright? Option 1 is to choose any point that would be on this line, and you can kind of fill it in. Or, if you've got the triangle, you don't have to worry about any of this stuff. You don't have to worry about choosing a point on the line because we know what the ratios would be because we've memorized the triangle. I know my reference angle is 30 degrees, so using this triangle here and rotating it, I've got a 30, 60, 90 triangle. And I can fill in the sides. My sides of 1, square root of 3, and 2. So what is the length, what's the measure of y going to be? It's going to be 1. That's the short side. Opposite the 30 is the short side. Y equals 1. What's the measure of x going to be? Square root of 3. It's opposite the 60 degrees. So opposite the 60 degrees is square root of 3. And what's my radius? My hypotenuse? 2. So I have those 3 values. Now, the only difference is when I'm in quadrant 3, okay, when I'm in that quadrant, x and y is negative. So we're going to change those to negative.
Why is the rate?
Two reasons. One,
It's both is double negative.
well, it's because we're squaring. Pythagorean theorem, we square the values. Once we square the negatives, they become positive. Second reason is radius measures distance from center. Distance is always positive. Okay, distance is always positive, so your radius will always be positive. All right. So now that we have that change, okay, everything's the same as 30 degrees except for the signs. X is going to be negative and Y is going to be negative. So all of our ratios will be the same except any that involve X or Y are going to be negative instead of positive. Okay. So we need to find the 6 values of our trig function. All right. So we've got our reference angle, we've got our x, y, and our r. So now we can fill in for sine of 210. And again, all of these values are based off of the reference angle of 30 degrees. Okay? How do I find sine? What 2 sides am I going to use?
Y and R.
Good. What's my y value? -1. There you go. -1 over 2. So 30 degrees, sine of 30 degrees is 1/2. Sine of 210 is -1/2. Same number, different sign. What do I use for cosine? X over R. So what's it going to be?
Negative.
Good. Okay. Sine of 30 degrees, or sorry, cosine of 30 degrees is √3 over 2. Cosine of 210 is -√3 over 2. What do we use for tangent?
Y over X.
Y over X. Okay. So what am I going to have? Well, it'll. So we'll have to rationalize. You got a little bit ahead of me, but yeah, you're good. You're right there. I mean, you were correct. Okay. So y is -1. X is -√3. I need to rationalize. How do I rationalize again?
Multiply with 3.
Okay. So -√3 over -3. And then when I have a double negative, what happens? It becomes positive. Okay. So there's my tangent, √3 over 3. Notice that tangent's positive. Because they're both negative in quadrant 3, tangent's going to be positive. So it's going to be the exact same value as tangent of 30 degrees. Because tangent is positive in both quadrant 1 and in quadrant 3. Over time, you should recognize a pattern of which functions are positive and negative in which quadrants. To start, everything was positive in quadrant 1. In quadrant 3, we're seeing that tangent's still positive, but sine and cosine are negative. Of cotangent, secant, and cosecant, which one do you think is still going to be positive? Based on what we have with sine, cosine, and tangent. Cotangent. Okay, cotangent, because it's the cofunction or the reciprocal for tangent. So what's cotangent going to be? Square root of 3. Go back to your original pre-rationalized value for tangent before you write your reciprocal. That way you don't have to rationalize it again. You can use square root of 3 over 3, but then you got to 3 over √3 again. It becomes a process. Go back to your original.
You rationalize it again.
Yes. You'll just have to remember to simplify the fraction. Secant is the reciprocal of which one? Cosine. So what's secant going to be?
-2.
-2 √3 over 3. We took -√3 over 2, wrote the reciprocal, and then we had to rationalize it again. Cosecant. -2. Reciprocal of -1/2 is -2. So there's our 6 trig functions again. A lot of repetition. We're going to see those values over and over and over and over and over. Now they look at it positive or is it negative? So we have to pay real quadrant that we're in to determine whether or not the value is going to be positive or negative. So, just kind of the general process when we're finding our trig function values for any non-quadrantal angle. That means anywhere within our coordinate grid. If our value is greater than 360 or less than 0, we need to find a coterminal angle first. Okay, so that way we can find out between 0 and 360. Then we find the reference angle. Then we can find the trig values for that reference angle. And then we just need to determine the correct signs based on what quadrant we're in. Okay, so let's run through those quadrants real quick. All right, in quadrant 1, I have x and y. Is x positive or negative in quadrant 1? If I have any point in quadrant 1.
Positive.
Positive, thank you. What about y?
Positive.
Positive. They're both positive. Okay? So that means everything, sine, cosine, tangent, cosecant, secant, and cotangent will all be positive. Because everything's positive. When I move to quadrant 2, what becomes negative? X. So for x and y, x is negative, but y is positive. So any of my ratios that involve the x value will become negative. Okay, so does sine use an x value? No, it uses y and r, right? What about cosine?
Yes.
Yes, so cosine will be negative. Does tangent use an x value? Yeah, so tangent will be negative. And since cosine is negative, which reciprocal has to be negative? Secant. And since tangent's negative, what else has to be negative? Cotangent. Okay? So those 4 values become negative once we move to quadrant 2. But sine and cosecant stay positive. When we move into quadrant 3, what becomes negative? Both. Quadrant 3, so x and y are negative and negative. Okay? So, any ratio that uses x or y but not both is going to be negative because we saw that tangent was positive, we saw cotangent was positive. So we know that sine and cosine and cosecant and secant, those were all negative. But tangent and cotangent were positive because of that double negative, because they use both x and y. What's negative in quadrant 4?
Y.
Just y. X is positive. X is positive. Y is negative. So then it's only the ratios that include y. So we're taking quadrant 2 and we're switching cosine and secant for sine and cosecant. But again, we're going to get tangent and cotangent negative again. So sine and cosecant and tangent and cotangent will all be negative, while cosine and secant will both be positive in that quadrant. Okay. So as long as you remember the ratios, you know x and y, where they should be positive, where they should be negative, it's a quick check to make sure you have the right sign, positive or negative, associated with whatever your trig function angle is. We're going to be seeing these angles a lot, and I want to emphasize and remind you, you need to know your special right triangles. You should be able to draw them by hand, on your own, on Wednesday, the 30, 60, 90, and the 45, 45, 90. If you can't, you will have trouble, because I will want exact values, and your calculator won't give you exact values. The only time you'll get an exact value is when your answer is -2 or -1/2. That's it. So you're missing out on 4 other functions. I wouldn't want to roll those dice if I were you. Questions, comments, concerns, queries, or? That's it, right? Oh, I got 4 more. Okay. Perfect. I was just ready to be done. Well, this will work out great. Let's keep doing it. Okay?
No.
negative angle, so what should I do first? Add 360. If I add 360, what do I get? 180. You sure? 120. Man, you made it right 180. Got in my head. Okay, so 120 degrees. So what's my reference angle going to be? I'm going to subtract it from 180. 60. So my reference angle is 60 degrees. So which triangle am I going to use? Well, I have two.
The 61.
The one with 60. The 30, 60, 90. Okay? So, if I have a 30, 60, 90 triangle, and this is 60 degrees, and that is 30 degrees. What's the short side? It's x, but what's the measure of x going to be? 1. Okay? But I'm in quadrant 2. What do I have to remember in quadrant 2?
X is negative.
X is negative. Okay? Try and draw a little negative. X is negative 1. What's the measure of y? Square root of 3. What's the measure of r? 2. Every single time. 30, 60, 90 triangle. The short side is 1. This other leg is root 3. The hypotenuse is 2. Okay? So now we can find all of our trig function values based off of that information. What's sine going to be? Square root of 3 over 2. Cosine.
Negative 1 over 2.
Tangent.
2. Negative. No. Sorry.
Negative root 3.
Opposite over the adjacent. Y over the x. So root 3 over negative 1 makes it negative root 3. Now we can do our reciprocals. What's the reciprocal of sine?
Over 3.
Yeah, but which function?
Yeah, what?
Which function is it?
Oh, cosecant.
Cosecant. What's the reciprocal of cosine? Okay, what function? Put the degree in the wrong. And what's our last one? Negative, so cotangent, and that gives me negative root 3 over 3. Same values, different signs, different order. Same 6 numbers. Over and over and over and over and over for all of our 30, 60, 90 angles. Whenever we have a reference of 30 degrees or 60 degrees, it's going to be those 6 values, either positive or negative. Can't get any more repetitive than that. All right? 675. What's my reference angle? Okay? So my co-terminal angle is 315. 315. What's my reference angle going to be? 45. Okay? So far we've been using the 30, 60, 90 triangle. Is that one going to help me here? No, I need to use my 45, 45, 90 triangle. 45, 45, 90. Who remembers what the legs of the 45, 45, 90 are?
Oh.
What's the hypotenuse? Not 2. Square root of 2. Okay? So, when I'm looking in my triangle here, what's my x going to be? 1. What's the y going to be? Close. Negative 1. I'm in quadrant 4. Change the sign. And my hypotenuse is root 2. like for that particular part, half.
Half a point.
If I want all 6 trig functions and you get the sign wrong on all of them, you'll lose half a point for each one.
Okay.
Or half of the points for each one. I don't know how many points each one is. Okay? Sine of 675, cosine of 675, tangent of 675, secant of 675, cotangent of 675, and cosecant of 675. There, I mixed up the order for you. Keep you on your toes. No. What sine is 675?
-1.
Mm-hmm. No, it's not. I was thinking tangent. Sorry.
No.
Not -1. The y is -1, but what else goes with it?
-1.
Yeah.
Is
-1 over root 2, which rationalizes to -√2 over 2. Cosine. Root 2 over 2. Because it's 1 over root 2. So it's positive instead of negative. Tangent. -1. That one's -1. -1 over 1. Secant. You were close.
Oh, secant, positive.
Positive root 2. Reciprocal of cosine. So it's going to be positive. Cotangent. Cosecant.
Negative.
-√2. Our 45 triangles only have those 3 numbers to deal with. Okay, same 3 numbers for every 45-degree angle. Every time we have a 45-degree reference angle. All right, same idea, but we don't have a graph. You don't need a graph. It's still the same thing. Do I start with an angle between 0 and 360?
No.
No. So what do I do to fix that?
Subtract this.
Subtract 360. We're going to do it twice because it's not going to work unless we do it twice. 2 rotations is 720. So what's 280 minus 720? 60. What quadrant does that put me in? First quadrant. Okay. So since I'm in quadrant 1, that means 60 degrees is its own reference angle. So I don't even need to go through the process of finding the reference angle. It is what it is. So usually it helps to draw a triangle in the quadrant. Doesn't have to be perfect. Let's say, oh, I'm in quadrant 1. Let me draw a triangle. That is a 60-degree angle. I've got a 30, 60, 90 triangle. What's the x side going to be on our 30, 60, 90? Is the x going to be our short side or the long side? Short side. It's opposite the 30. It's going to be our short side. So what measure is that? Y'all should be referencing that triangle non-stop so you have it memorized by Wednesday. Alright? The side opposite 60 is going to be what? Root 3. The hypotenuse is going to be what? 2. Sine, cosine, and tangent. Sine is root 3 over 2. Cosine is 1/2. Tangent is root 3. And then write your reciprocals for the rest. Let's finish up on -405. I need to get my reference angle. Or sorry, I need to find my coterminal angle first. Add 360. We're going to have to add 360 twice. -405 plus 270. If you add 360, you're still going to have a negative number, so we need to do it again. That's what 270 says. What quadrant does that put me in? Puts me in 4. We already did that one there. Okay, so 675 is coterminal to the what was it, 405? So all those function values are going to be the same. It's so repetitive. You just have to know your special right triangles. If you don't know your special right triangles, you're up the creek. You got to memorize them. Special right triangles signs based on the quadrant, and that's it. That's the hard part. Once you got those, it's just filling in the ratios. You'll be doing the same numbers over and over and over and over and over and over and over again. Some of you may memorize some of these. All right.